Okay, so I just wanted to finish up number 21 because we'd done all this work, and I made some mistakes. So after completing the first derivative test, right? So after completing the first derivative, like, this was all correct, and then when I took the second derivative, this is correct as well. It's just that when I went to expand this stuff, I made several errors, actually. So I was wrong on the signs on a couple of terms, and then the very last term I put down 27 when it should have been 9, which is kind of strange. I just wasn't paying close enough attention, I guess. But anyway, this is the second derivative that you should end up with, of course, divided by x squared minus x plus 1 to the 4th power. So I'm just going to transfer all of this work over to this page. So this is basically what we should have at this point. So we took the first derivative and simplified it, and this is what we got. Then we found the critical values, critical points, and determined where the function was increasing and decreasing. And I'm calling this thing the first derivative test. Really, the first derivative test is to help you find maxima and minima, which we weren't really asked to do. We were only asked to find intervals of increasing and decreasing. So, so we don't. I'm not going to go back and do the second derivative test, which is what I said that I would do that in the Zoom meeting, but it's not necessary to do that on this problem now that I read through it again, because we're not being asked to find maxima and minima. And that's what the second derivative test is for. The first and second derivative tests are for finding maxima and minima. They both do the same thing. But they're both to find maxima and minima, and since we weren't asked to do that, it doesn't really make sense to go back and do second derivative test. This is all the information that we really were asked for. And so we're done with parts A and B. As far as parts C and D are concerned, when you take the second derivative and simplify it without making these mistakes in arithmetic that I made when expanding this part of it, then this is what you should end up with. Okay, so this is what you should end up with when you finish taking that second derivative. And so now, it's to complete parts C and D, well, actually to complete parts C, D, and E, right? So to find concavity and inflection points and all of that. Now we have to figure out where the second derivative is either 0 or undefined. The denominator is never going to be 0, and so that means that the second derivative is never going to be undefined. Okay? We know that from the work that we did in the Zoom meeting, so you can check that again. However, the numerator could be 0, and wherever the numerator is 0, the second derivative is 0. So let's set the numerator equal to 0 and solve. Okay, so then you get 6x equals 0, or this thing equals 0. So I'm just going to go ahead and jump to quadratic formula since I don't think that thing factors, but I'm going to say x equals negative b plus or minus the square root of b squared minus 4 times a times c. That's 4 times 2 is 8 times 5 is 40. So 64 minus 40 over 2 times a. Okay, so 64 minus 40 is 24. 24 is 4 times 6, and the square root of 4 is 2. So I can take out a 2 and be left with a root 6 on the inside. And then I can simplify by 2 and get 4 plus or minus root 6 over 2. And then here I'm just, of course, going to get x equals 0. But now I have to do the same thing as I did up here, and to figure out where it's concave up and concave down. So let's see, 4 minus root 6. I've got to get these in order. So 4 minus root 6 over 2 is approximately 0.77. So 0 comes before that. So I'm going to go from negative infinity to 0. Then I'm going to go from 0 to 4 minus root 6 over 2. Then I'm going to go from 4 minus root 6 over 2 to 4 plus root 6 over 2. And then I'm going to go from 4 plus root 6 over 2 to positive infinity. Okay? And then I'm going to figure out the sign of f double prime. Okay? So to figure that out, right, I just plug in test points here to my second derivative. So plugging in something less than 0, like negative 1, I'm going to have a negative times a negative 1. This is going to be positive, this is going to be positive, and positive, so that'll be positive. And the denominator is always positive, so this is going to be negative here. That tells me that I'm concave down from negative infinity to 0. Between 0 and 4 minus root 6 over 2. 4 minus root 6 over 2 is like 0.7, so that's kind of a rough one. But if we plug in like 1/2, that would be inside of this interval. So positive 1/2, that's going to be a positive number. 1/2 here, oh goodness. So that's going to be so that's going to be 1/4 times 2, so 1/2 minus 4 is like negative 3.5, but then if I add a 5, it's going to be positive still. So positive, positive, positive. So it's still going to be positive there, which means I'm concave up. Okay. Between 4 minus root 6 over 2 and 4 plus root 6 over 2, let's see. 4 plus root 6 over 2 is about 3.2. So I can choose like 1. 1 would be inside of this interval. So if I plug in 1, this is going to be positive. This is going to be 2 minus 8 is negative 6 plus 5 is going to be negative. So that's going to be negative, concave down. Okay, and then finally something bigger than 4 plus root 6 over 2, that's again about 3.22. So if I plug in like 4, then it's going to be positive. Here I'm going to be 4 squared is 16 times 2 is 32, and then 4 times 8 times 4 is 32. 32 minus 32 is 0, but then plus 5 is going to be positive, so it's positive again. So concave up. Okay, and so there are your answers to parts C, D, and E, right? You're going to be concave up on these two intervals, concave down on these two intervals, and so then you're part E just asks for the x coordinates of the inflection points. So the x coordinates of the inflection points would be 0, 4 minus root 6 over 2, and 4 plus root 6 over 2. So that'll do it for number 21. Let me check the solution actually. Yeah. Okay. So that's that. So I apologize for making the arithmetic mistakes here on the second derivative when I was simplifying it, but that's how the problem should have ended, I suppose. So that's it for 21.